RHINO Management would like to thank you for your interest in our steel building systems and for taking the time to review this presentation of erection procedures. RHINO is one of the nation's leading suppliers of pre-engineered steel buildings with products across the nation. With 7 shipping locations from Georgia to California, RHINO customers can realize significant savings in delivery expenses. Over half of our customers elect to take advantage of our all bolt-together pre-engineered designs by erecting the buildings themselves, saving even more in construction costs. Each building is pre-engineered to meet the wind, snow, and seismic requirements of your particular location. This presentation, along with the RHINO Steel Erection Manual, are designed to work together, giving you the necessary information to erect the building in a professional manner. And if any questions do arise, you are always just a toll-free call away from RHINO's Technical Assistance Department. Every RHINO Steel building owner receives a letter of certification, permit, and erection prints stamped by an engineer licensed by your state. These instructional prints cover each and every phase of the erection process, including a complete anchor bolt diagram, building frame reaction to design concrete or footings, roof framings, sheeting installation steps, and many more erection details for all parts of the structure. You will also receive a comprehensive shipping list. As you unload your building, it is important to check off all items. After placing an order for a RHINO building, the normal sequence of events include, number 1, a letter of acceptance with our thanks for your order. Number 2, a letter to you stating a tentative delivery date. 3, your receipt of anchor bolt plans and drawings for permit approval. 4, a confirmation letter sent to you stating the day and time of delivery. 5, a follow-up phone call to you reconfirming the time of building delivery. And 6, the delivery of your building. The entire process usually takes approximately 6 to 8 weeks. If your needs dictate a quicker than normal delivery, we will look at each individual situation to try and accommodate your time frame. Our goal at RHINO is to fulfill your building needs with a great product at a competitive price, and to make your buying experience a satisfying one with no surprises and a structure you will be proud of. Now, let's take you through the construction process. It is extremely important that anchor bolts be placed accurately in accordance with the anchor bolt setting plan. From this anchor bolt setting plan, we see that there are anchor bolts on both end walls at 4 different locations, 20 feet apart. There are 2 anchor bolts at each location. Anchor bolt locations can also be found at each end of the main center column. The detail sheet shows specific requirements for each anchor bolt setting. For example, this detail sheet tells us to use 2 3/4 anchor bolts 3.5 inches apart at this specific location. They should be placed 2 1/4 inches from the steel line, with the concrete line another 1 1/2 inches extended, showing a total measurement from the end wall length. The side wall should then be 8 inches from the steel line, with another 1 3/4 inches to the center of the anchor bolt, for a total of 9 3/4 inches from the edge of the concrete. To make this easier, we have taken a piece of 1/2-inch plywood using appropriate measurements and have made a template to nail to the form for exact anchor bolt placement. The template will remain attached to the form, keeping the bolt steady while the concrete is poured. As the concrete is being finished, the nuts can be taken off the bolts and the template removed, allowing you to finish the concrete in the area exposed by the plywood template. Remember, at each anchor bolt location there are different settings, so always consult the detail sheet for precise specifications at each location. Careful planning both before and during the unloading process is important in order to eliminate unnecessary work and to ensure that all materials are present and undamaged. When the truck arrives, it is important that it be placed near the slab, but far enough away to allow for plenty of room for the unloading equipment to maneuver around the trailer without getting too close to the edge of the slab. Overhead power lines are a continuing source of danger. Extreme care must be used in locating and using lifting equipment to avoid contact with power lines. The type and size of lifting equipment is determined by the size of the building and the site conditions. Length of boom, capacity, and maneuverability of lifting equipment will be determining factors for selection. When the items, boxes, crates, bundles, or other large components are received and unloaded from the carrier, they should be checked off from your RHINO packing list. If during the inspection, damages or shortages of items are found, a report should be filed with the carrier driver immediately at the site. When damages are evident from the exterior of containers, they should be opened and inspected thoroughly at the time of receiving shipments. Also, when the bundles, crates, cartons, and boxes are opened following delivery, another check must be performed to determine the quantity received and their condition. If during this inspection damages or shortages of items are found upon opening the crates or cartons, you will follow the procedures outlined in your RHINO erection manual. A phone call to RHINO will get this process started, and the missing or damaged items will be promptly delivered. Special care should be taken when unloading stacked sheathing material. First of all, the forks should be inserted at exactly the center point underneath each stack. Additionally, when moving the sheathing to its temporary location on the site, it is important to go very slowly, as to not allow the sheathing to bounce up and down. And finally, when placing the sheathing on the ground, be sure to place boards underneath and place one more board at one end so that rainwater or dew will drain off to one side. These steps will prevent possible water staining and discolorization. To aid in centering the forklift underneath each stack, RHINO inserts a red tag with a mark on each stack designating the exact center point. Proper placement of materials around the site can eliminate excessive work time. Columns and rafters are usually unloaded near their respective installed positions for easy makeup. All red iron should be placed on wooded blocks. End walls are usually laid out at each end of the slab with the columns near the respective anchor bolts. Place all other materials as close to their respective erection points without blocking the free movement of equipment. This particular model is 60 feet by 60 feet in size. The framing structure will consist of one center bay with end wall bays on each side. The center bay consists of two rafter columns and a rafter that comes in two pieces. Here you are viewing the first rafter column being lifted into place over its corresponding anchor bolts. The center bay will bear most of the load of the building and is made of a much heavier gauge of red iron than other parts of the structure. As the first column is laid into place over the anchor bolts, it is then securely fastened. Metal buildings are among the strongest structures in existence, but ironically do not achieve their full strength until all purlins, girt, and sheathing are attached. Therefore, it is recommended that the basic framing parts be partially secured as they are erected. Here you see a purlin being attached to the first two rafter columns before any other erection continues. When permanent cross bracing is not used, it is important to install a temporary stabilizing cable between the two rafter columns. This is accomplished by drilling a hole in the slab and affixing a set screw, attaching the cable and adjusting the cable length so that the column is perpendicular to the slab. At this point, you may use a level to roughly plumb the column. A more accurate plumbing of the structure will be performed later in the erection process. You will then tighten the cable for the desired stability. After the sheathing is put up, all temporary stabilizing cable attachments will be detached. On larger models, permanent cabling is required and furnished with your shipment. The center bay and one end wall bay are now erected and secured by a single purlin and cabling. The next step will include the attachment of the rafters to the columns. While there are several methods for accomplishing this step, here the erectors will move each rafter half-section into place and lay them on the slab. They will then carefully line up each end and bolt together. The completed rafter is then lifted into position over the columns and bolted together. Here you see the two center bays completed. Similar to the rafter columns, some interim bracing should now be accomplished by installing a single purlin between the bays and attaching diagonal cable bracing on each side in order to secure the structure against high winds. Additionally, the erectors will attach a single girt between the rafter columns on each side. Since the center bays will carry most of the load of the structure, the end wall materials are manufactured with lighter gauge columns that can be easily placed without the need for heavy equipment. Upon completion of each end wall, diagonal bracing is again necessary for temporary stability and protection. After the bays and end walls are completed, the remaining purlins and girts are attached and the basic structural framing is completed. It is important to note here that all purlin, girt, and eave strut connection bolts be only hand tightened so that the entire primary framing work can be plumbed without undue difficulty. The remaining purlins can be positioned on the rafter in each bay to facilitate the completion of the roof framing. You will notice here that the purlin length is different between the end bays and center bay, as opposed to the length between the bay and the end wall. Typically, the end bay purlins are of different lengths than the center bays. It is important to take note of this and refer carefully to your plans in order to install the correct purlin lengths in the right location. This model calls for an overhang from one end wall. Overhangs can be added to any model up to 5 feet in length at little cost. While there are different types of rafter and column arrangements, this model uses straight columns with inset or flush girts and overlapping purlins interlocked for greater strength. RHINO buildings feature additional bracing using flanges attached from the purlins to the rafter and girts to the rafter. This ensures that the frame cannot twist under load. Here we see another building with tapered columns. This configuration is normally designed for buildings of greater width. An important feature on the majority of all RHINO buildings includes pre-welded clips on all purlins and girts for attachment. This is a significant time and labor-saving feature in the erection process. It is now time to plumb the building. You can use the plumb bob method, or by using a transit, you can plumb a single bay and the entire structure will be plumbed. First, be sure that your transit is lined up perfectly level and perpendicular to the selected bay column. Using a measuring tape, line up the transit a few inches from the columns and take a reading at a point on the measuring tape and adjust cable bracing to plumb. Take another reading at the rafter peak and adjust the diagonal cable lengths between the bays to get an equal reading from column to rafter. Take a final reading on the far rafter column. If both columns and rafter are plumb, the entire structure is now plumb. You will now tighten all connection bolts and anchor bolts per the bolt tightening procedures explained in your erection manual. The next step involves the installation of the top trim plate and base angle. These parts allow for the attachment of the outer sheathing. Here, we see a top trim plate being lifted into position on one end wall. All top trim plates screw to the purlins at both end walls. Before drilling, it is best to clamp down the trim. Then drill your holes. The base angle is installed differently. Holes are punched into the base angle and then positioned at the edge of the slab. Using a 5/16 concrete drill bit, a hole is drilled into the slab, providing for set screws to be hammered through the plate, thus securing the base angle all around the slab. After installation of the top plate and base angle, the structure will be ready to accept the outside panels. We see here that the slab has been recessed in order to provide a place for the sheathing to rest on. Here is another area of the slab that has been specially recessed. This recessed area is located at the spot where an overhead door is installed. The frame rests in this recessed area below the slab surface so that any water driven by the wind will not enter the building. Before an overhead door can be installed, a framed opening is erected on one side wall. Attachment to the main frame is accomplished using these clips that allow for a simple bolt connection. The vertical studs then drop down in the recessed notch in the slab as previously explained.